Alright, hello geometry friends. Hope everybody's doing well. Today we are going to start trigonometry, which is very exciting. It's one of my favorite topics to teach, and it's just pretty darn cool. So grab your calculator, grab a pencil, grab your packet, and hopefully you're ready to go. This is a review of what we did on page 19 before our quarantine. So just a quick reminder, these are review concepts. If you have a right triangle, the sum of the two acute angles is 90. So if you are missing an angle, you just do 90 minus the angle that 90 minus the angle that you have to get the missing angle. So here we did 90 minus 20 to get the 70. And then the review concept number 2 that we talked about is I had not highlighted in class, but in Ms. Mickis's video, she was highlighting the hypotenuse, and that's a really great strategy. So I'm going to steal her strategy. And once you highlight the hypotenuse, then you know that the other two sides adjacent to the right angle are both legs. Okay, so now we're going to flip over to page 20. And off we go. So identifying opposite and adjacent angles. In a right triangle, the adjacent leg to the acute angle is the leg next to the angle. The opposite, so adjacent is next to, opposite is across from the angle. So, of course, this isn't the best highlighter, and it's pink, and it's really, I don't know, I think it's dying, but hopefully it can get me through for 10 minutes or 15. All right, so for this one, we usually kind of come up with cute names in class, and I hope you can appreciate this. But while you're quarantined, do not become a fat pig. Ha, 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 ha. Seriously, if you buy snacks for 3 weeks, don't eat them in 3 days. Okay, so what I'm going to look at now is we're going to label each side of the right angles as the adjacent angle, opposite leg, and hypotenuse. So you're going to pick your reference angle. So this time I'm going to pick angle T, for example E. And remember, we're going to highlight our hypotenuse. So this is my hypotenuse. I like to call it a capital H. The side across from the T is the opposite side, so I call that an O. So I look at the reference angle and I go across to get the opposite, and next to is the adjacent. Okay? Now, just if you think about it, if I had picked angle F instead, this would be reversed, and that is an always. So if you pick the other acute angle, your opposite and adjacent sides always change. Okay, in example F, let's do the I. Okay, so our acute reference angle is I. The right angle can never be a reference angle. Right angle is just the right angle. Across the right angle is always our hypotenuse. I'm going to go ahead and highlight that, and that will be H. Okay, and then across from angle I is the side opposite, and next to angle I is the side adjacent. If you can label the sides correctly, that's half of the battle. Now we're going to go on to our trigonometry, and it's pretty exciting because now you get to learn what the sin button is on your calculator, but it's actually not sin, it's actually sine. So you have a sine button, a cosine button, and a tangent button. And I think I'm going to write that over here. So this is sine, this is cosine, and then this is tangent. I feel like you should properly meet your 3 trig functions, and then you can go on a nickname basis with them. So cos, but I always say the whole word. I always say cosine, but you can write it abbreviated. I like to use SOHCAHTOA. If you literally go into Google and you type in SOHCAHTOA, all the stuff on what we're doing right now will come up. This is a widely known acronym. And the S stands for sine, the O and the H and the A stand for opposite leg, adjacent leg, and hypotenuse. And the S stands for sine, the C stands for cosine, and the T stands for tangent. When you're looking at these trig ratios, I skipped a couple pages in this packet where you would have had we've been in class, measured different sides, and found that there's a consistent relationship with all triangles that have the same, all right triangles that have the same acute angles. And it's kind of cool that we could look at it that way. So I'm sorry you're missing out on that experience to know kind of where the numbers are coming from. But ancient mathematicians had done that over and over and over again and found that these proportions and ratios held true. So that's why we have trigonometry. All right, so we have the sine of A is the ratio of the opposite leg over the hypotenuse. And where this is coming from is you have the S, the O, and the H, and that is getting you your SO. And then the cosine of angle A is the ratio of the adjacent leg to the hypotenuse. I'm literally reading this word for word. And when I say angle A, it's always an acute angle, never the right angle. So I have the cosine, the C is of an angle, A is the ratio of the adjacent side, adjacent leg to the hypotenuse. So that's your K. And then the tangent of angle A is the ratio of the opposite leg to the hypotenuse. So T and then O divided by A. Okay, except I have a typo. Oops. 2 is the ratio of the opposite leg to the adjacent leg. All right, so now that we know that, we're going to flip over to page 21 and we're going to start using our calculator. Okay, so we're going to find the sine, the cosine, and the tangent for each acute angle. And right now there's no labels here, so I'm going to put a 5, a 12, and a 15. 13, 5, 12, 13. So that's one of our special right triangles, if you remember that. It's like a 3, 4, 5, but it's a 5, 12, 13. So I'm going to circle S out of triangle QRS, and to be proper, I really need the right angle there. So I know it's a right triangle. Okay, so relative to angle S, we're going to highlight the hypotenuse. Okay, and I'm going to call this side H. And take a moment and decide which side is opposite angle S and which side is adjacent to S. Okay, this one is opposite, the 5 is opposite, and the 12 is adjacent. You can always pause me too if I ask a question, which I probably should have told you before I gave you the answer, so that wasn't very helpful. All right, well, here we go. All right, at the top, I'm going to write so, ka, toa. I'd like you to memorize that. And the other thing that I meant to say, and I didn't back here, is I would literally say these a few times, like maybe go back, pause the video, and say these a few times. And then you might want to say them when you come back to math a day from now or whatever, and just keep reciting that because it'll help you learn it a lot better. You could say it in a mirror, you could say it to your mom. This is what I learned in geometry right now. The sine of the angle is the ratio of the opposite side to the hypotenuse, and your parent might say, I loved that or I hated that, and they might have a real opinion. Okay, anyway. So we're going to do the sine of Q first, which is not what I have here. So we had to prep Mrs. Levine. So let's go down to S because that's what I circled. So I have the sine of S, and I want to do the ratio of the opposite side to the hypotenuse. So I'm going to do, in this case, the 5 is opposite. So that's going to go in my numerator of my fraction, is the ratio of the opposite side to the hypotenuse, and then the 13 would go in the denominator, and then you can take your calculator, and we can do 5 divided by 13, and I'm going to round to 4 decimal places. So I'm going to write 0.3846. If the next digit is a 5 or more, you round up. So if you have a hard time with rounding, just a reminder, I have 1, 2, 3, 4 digits. If this one's a 5 or more, the 6 would have come up to a 7. Okay? All right, now we're going to do the cosine. So the cosine of S is the ratio of the adjacent side to the hypotenuse. So the adjacent side is 12, the hypotenuse is 13. So I'm going to do 12 divided by 13. And now this would be a case where I do have to round up. Okay, so I have 0.923076. So I'm going to put my line here, and the 7 is going to bump that up to a 1. So I have 0.9231. Okay. And then finally, tangent is going to be tangent of angle S is the ratio of the opposite side to the adjacent side. So this will be 5 over 12. We'll do 5 divided by 12. And again, 4 decimal places, you don't have to write out all this stuff unless you really need to. But since the next digit is going to be a 6, that's going to round that up to a 7. Okay, so I mistakenly did the bottom half first. It really doesn't matter. Now I need to change my reference angle. So instead of doing angle S, I'm going to do angle Q. So I'm going to kind of X that out. It's hard to do with a pen, but I'm doing a pen so you can see it better. I still would like you to be doing your math with a pencil at home. Across from angle Q will be the opposite side. And next to angle Q will be the adjacent side. So I mentioned this on the last page, that those will always switch around and always be reversed. The hypotenuse will never change. So once you've identified the hypotenuse, it stays at forever. All right, so for the sine of angle Q, we're going to do the ratio of the opposite side to the hypotenuse. We're going to do the cosine of Q and the tangent of Q. Go ahead and pause the video and try those with a fraction and the decimal. Okay, so I'm going to do the ratio of the opposite side to the hypotenuse. That's going to be 12 over 13. And then I actually already did that. Holy cow. So that's going to be 0.9231. Did you recalculate it, or did you realize you already had it? Okay, hopefully you realize you already had it. And then the cosine of angle Q will be the ratio of the adjacent sides of the hypotenuse. So that's going to be 5 over 12. 5 over 13, sorry. And that's going to be 0.3846. And then you can kind of see that these go together and those go together. Okay, and that is something that I might have you watch a video on Khan Academy about that. So that's always a true. And then the tangent of angle Q is the ratio of the opposite side to the adjacent side. So that's going to be 12 over 5. So we're going to do 12 divided by 5, and that's going to be 2.4. And this calculator does have a reciprocal button. I think if I press this, it'll do 1 over 2.4, and then I'm going to convert it, and holy cow, I get this one. So these are reciprocals of one another. So if I do 1 divided by my answer here, I get the 2.4. And if I do 1 divided by 2.4, if I lost you with the reciprocal, this is a reciprocal button. This is the answer button. You can do it that way. I will show you some things as to how to use your cell phone, but I'm going to hold off on that for these because these are pretty easy calculations. Okay, so these are reciprocals. Tan of Q and tan of S are reciprocals. Okay, and then these are the same. So the cosine, the sine of Q equals the cosine of S, and the cosine of Q equals the sine of S. Okay, so let's keep going. I'm going to go over to page 22. And now we get to either use our calculator or a chart to find trig ratios. Most of you are just going to want to use your calculator, and we're going to round to 4 decimal places. So I would prefer that you use a calculator, a scientific calculator. It's not required, but I do prefer it. Make sure you are in the right mode. So I'm going to go into the mode on my calculator, and I have to make sure that I'm in degrees. And Algebra 2, you'll learn about radians, but I'm in degrees. Those of you who like that function with a radical, that's the math print menu. If you wanted to turn that off, you would go to classic. All right, and I'm going to do second quit. All right, and now these are the trig functions on your calculator. So the sine button, the cosine button, and the tangent button. So you've seen those like for years, right? You never knew how to use them. Guess what? Today is your day. So on this calculator, I like this calculator because you just literally type in sine of 20 and hit enter. And it's really intuitive. Some of you may have another scientific calculator and it might be reversed where you type in 20 and then sine and then you get the decimal. So just get comfortable with your calculator. You're going to get 0.3420. And I do want to show you how you would do this on a phone. So here's my family. It's a little blurry, I guess, or bright. But I'm going to go into my calculator here, and my calculator comes up. And then I'm going to turn it. And all of these functions come up. It's a little bit hard to see that. So let me see if I can kind of play with the lighting to make that better. Ooh, it's really bright. It could cooperate. It's a little bit better, not a lot better, but I'll take what I can get. All right, so if you wanted to do this on this calculator on here, I think you do 20 and then hit sign. But see, if you notice, I have rad there, so I'm in the wrong mode. So I have to change it to degree. I'm going to do the sign of 20, and that's not right. Okay, so let's try this again. And this kind of stuff might happen to you, so I don't know why. Okay, so, okay, maybe I was in degrees, but I don't know. Oh, here it is. Sorry. I'm not that good enough to know how to pause it and rewind. That feature doesn't come up in this menu, so I'm just going to go with it. All right, so this is Levi making a math mistake here. So I'm going to have 20, and then the sign is this key here that I'm pointing to. So I'm going to hit that, and I get my exact number there. Okay, so you can do either one. Take a moment, and you should be able to do all of them now. So cosine of 75. And then I get this crazy thing, so just convert it. Or if you want, you can change your mode here to classic. And then you're in classic mode, so that way when you do cosine of 75, you just go right to the decimal. Otherwise, you have to convert it using this key. Go ahead and pause me and fill those in. All right, and then you should be getting 0.2588. And I have 0.2126. Be careful if you're rounding. And then, oops, I have sine of 43. And I get 0.68. And now this one was 199. So when this one bounces up, the other one will go up. So you kind of have to carry the one. There's a lot of jokes about parents trying to teach elementary school kids to carry the one because we do it differently. All right, and then this one was 0.15. That's because this is one of our special right triangles, and so is the tangent. So remember, if you're doing tangent of a 45-degree angle, and this is 45, and this is 45, this is x over x. So when you do x over x, it simplifies to 1. And here, if you do the cosine of a 60-degree angle, you're doing the adjacent side to the hypotenuse. So this was across from the 30 is x, this is x root 3, and then this is 2x. You're doing x divided by 2x. So this is the adjacent, this is the hypotenuse, and this is your 30-degree angle. So across from the 60-degree angle is the x root 3. Adjacent to it is the side across from the 30, which is x, and then the hypotenuse was 2x. So when you do the cosine of 60, you get x over 2x, which is 0.5. So it goes back to what we were just doing. If I lost you in those last 45 seconds, don't worry about it. You can just do it right in the calculator. Okay. So hopefully you are doing well so far. And now we're going to do some review on proportions. Okay. I'm pretty sure that you can do number 7 on your own. Go ahead and do that. And you can pause the video. Okay, I'm going to cross multiply. I'm going to get 2x equals 3 times 14, and I get 42. Divide each side by 2, and I'm going to get x equals 21. Okay? All right, and number 8, it's a pretty easy problem. Just want to remind you that this number here is always over 1, so you can always solve these as a proportion. But a lot of times people just like these because you do 9 times 8, and you get 72, and that's fine. Okay. These 2 questions, I like to teach my students a trick for questions like 9 and 10, and I would like you to use the trick because I find that in general you do better. You just have to be able to identify the difference between number 7 and number 8. So take a moment and decide, well, 7 and 8 go together, and so compare 7 and 8 with 9 and 10. Here in 7 and 8, the variable's in the numerator. Okay, in 9 and 10, variables in the denominator. So when you're in the numerator, we're going to cross multiply like normal. Cross multiply. Variable in the numerator. Variable in the numerator, cross multiply. All right. Here, it's a lot easier to do what I like to call a switcheroo. So I had showed you this a while ago, that let's say you had 1/3, you don't have to write this down, 1/3 equals 5 out of 15. We agree that that reduces to 1/3. So I can, and you could divide that to get 1/3, but watch if I just switch. It's called like switching the means. So let's say I switch those and I get 15 over 3, I would get 5 over 1. Whoa, those are equivalent. And that's very helpful in this case here. So what I'd like you to do is when the variable's in the denominator, switch the means. When variable is in the denominator, switch the means. Okay, so what that means is these are going to be switched. So now I have x equals 15 over 5. Well, wait, 15 divided by 5, you get 3. Same thing here. This 4 is over 1. You can switch it, and you're going to get x over 1 equals 52 over 4. And you're going to get 52 divided by 4, which is 13. Okay, and I'm going to show you the other way that you could do a question like that. So I'll just do it for number 10. So for number 10, so I'm going to go ahead and kind of box that. And I would highlight both of those so you have them. This highlighter's not great. Okay, and for me, if you can get all this down, you're going to be in good shape. But the other way to do number 10 would have been if you have 4 equals 52 over x. To me, this is a lot more complicated. I would have to put the 4 over 1. I'd have to cross multiply, and I get 4x equals 52, and then divide each side by 4, and then I get the 13. So it's a little longer. It's actually not that bad in this case, but once you pull in the trig functions, it is quite a bit harder. All right, let's go over to case 1 and case 2. So case 1 versus case 2. So case 1, the variable is in the numerator, which is what we just talked about over here for 7 and 8. So when the variable's in the numerator, this is like it's over 1, and you can just cross multiply your means and extremes in your proportion, and you'll be good to go. So I have x times 1, and I get x. And then I'm going to do, I like to put the number in front of the trig function. So I would write 13 times the cosine of 18. And then that's actually a very easy calculation to do on your calculator. I actually had a 13 in there, but I pretended I didn't. So I hit clear. And I'm going to do 13. And you don't even have to hit the times button, times the cosine of 18. And voila, I get 12.36. 37. So I would say in general, probably go to 2 decimal places for the sides as you go through. So that one was pretty straightforward. I will show you that on your phone just so you kind of know what you're doing there. And I lost it. You might have said, Mrs. Levine, you lost it a long time ago. All right, so here we go. I want to do 13 times the cosine of 18. So I'm going to come over here and I'm going to type in 13. And then this is where it's kind of weird. You're going to do 18 cosine and then hit equals. And that did not work. All right, so let's try that again. So maybe I would do 18 and then the cosine times 13. All right, so did you see what I did there? So I did the 18 cosine to get that part first, and then I did times 13. That's probably the easier way to do it. It should have worked the other way as well. So And it did that time. I don't know why I didn't the first time. Maybe I typed something funny. So it should work either way. So you can do 13 times, and then you would do 18 cosine, but then you have to hit enter a second time, because when you get 18 cosine, it gives you that number that you had found at the top of the page. So you have to hit enter a second time, otherwise you will not get the right answer. This to me is a little complicated, so I would prefer that you use your scientific calculator. If you have an older sibling and you are using a graphing calculator, you can do all of this on a graphing calculator, but just be careful because an older sibling might be in the wrong mode. So mode up here, like right now I'm doing some work in my Algebra 2 class, but I'm not in, I do that in not degrees, but radians. So I would have to convert that to degrees. And then I could do the same thing here and do 13 times the cosine of 18, hit enter, and I would get my answer. So you have some options. Pick one and go with it. All right, over here, this one I'm going to do the trick. So the variables in the denominator, I'm going to switch the means. So that means that x is going to go here. So it's like x over 1, and you're going to have 9 divided by the tangent of 64. So that means you will do 9 divided by the tangent of 64, and I would get 4.3895. So we're going to go to 2 decimal places, which is 4.39. If you do not like the trick, you can certainly do this. When you had your proportion here, you're going to get the tangent of 64 times x equals 9. And then this is like a number, and you would divide each side by the tangent of 64. And you're going to get the same calculation that I just got, but I was able to do it really quick by just switching the means. And yes, you can do it out, and that's totally fine. And if that's the way that works for you, that's fine. But I guess I always feel like if I have a better way to do things, I don't make students do the long way. So that's just kind of how I do things. All right, let's flip over to page 23. Bear with me for a few more minutes. I know this is kind of a long video, but if you need to take a break, go ahead. But otherwise, I am going to keep going. I'm having a lot of problems uploading things, so I just would like to try to finish and get this done in one sitting, but you could pause it and come back. All right, so we're going to use trig to solve for the side length. We're going to find x and y, and we're going to round to, let's do the tenths. I guess that's fine. So we'll do 1 decimal, please, as you go through. All right, so you are given the acute angle here. You're given a right triangle. The acute angle is 36. Just for fun, even though you're not asked, get in the habit of doing 90 minus 36 because you're going to be doing that the following week. So this is a 54-degree angle. You can do everything with a 54-degree angle, but it will be reversed or reciprocal. We just studied that a few minutes ago. So just be consistent with your reference angle. Always highlight your hypotenuse. So highlight hypotenuse. You've got each there. So I'm going to call this 15 my hypotenuse. And then across from the 36-degree angle is the opposite side. Next to the 36-degree angle is the adjacent side. And I'm going to go ahead and write SOHCAHTOA on the top of my page, because now we're going to kind of pull everything that I've just been talking about together. And now you're looking at a triangle and you're trying to find a side length. Okay, so now what I'm going to do is, if you notice, I am going to write this really small. So SOHCAHTOA. I have a variable for a side, I have a variable side, and I have a side that I know. So the side that I know is the hypotenuse. So watch what I'm going to do. I know the hypotenuse. Ooh, check. I know the hypotenuse. Check. Tangent doesn't have hypotenuse. So that means I'm going to do sine and I'm going to do cosine. So I'm going to do the cosine of the 36-degree angle equals the ratio of the opposite side divided by the hypotenuse. I think I said cosine, I meant sine. So the sine of the 36-degree angle is the ratio of the opposite side divided by the hypotenuse. So this is going to be x over 15. And so we just made the equation that you were given back here. So we've done the solving here, okay? And now you just have to write up your own equation. Okay, and that's what we were doing kind of before, where you were kind of practicing that skill. Variables in the numerator, so all you have to do is cross multiply. If you want to put that over 1, you certainly can. You're going to get x equals 15 times the sine of 36. Okay, you're going to grab your calculator and go. You're going to get 15 times the sine of 36, and I would get 8.8167, so I'm going to call that 8.8. And if you want, you can go ahead and write that in for x, so that is 8.8. I also said that we were going to do the cosine. So now we're going to do the cosine of 36. And I'm going to write this up high because I want to use a little bit extra workspace. So the cosine of 36 equals the ratio of the adjacent side to the hypotenuse. Cosine is of the angle is the ratio of the adjacent side to the hypotenuse. This is why it'll help you if you kind of memorize those and kind of just keep reciting them. You'll get them down better. So the cosine of 36 is the ratio of y over 15. And then you're going to cross multiply variables in the numerator. So this is pretty straightforward. So y equals 15 times the cosine of 36. All right, and then you're going to do 15 times the cosine of 36, and you're going to get 12.1 and change, but I just said to round to 1 decimal place, so the 12.1 is fine. And I'm going to write that in. And I want you to take a look at our answers and say, wow, did those make sense? So if you look here at our triangle, I have a right angle. Okay, I know that the sum of the two acute angles add up to 90. This is the smallest angle in this triangle. Remember, it has to be across from the smallest side. So this is review concepts from, I think, the first half of the year. So the 8.8 is across from the 36. The 12.1 is across from the medium angle, the 54 degrees, and then the 15, the largest side, is across from the largest angle. So largest angle across from the largest side, medium size angle across from the medium angle, smallest angle across from the smallest side, and voila, jazz hands, you got it. Okay, but wait a minute. Mrs. Levine, we found that this was 8.8 over here. Couldn't I have done Pythagorean theorem to find the third side? And guess what? You could have. So, and you don't need to do any of this, just watch. You would have had y squared plus 8.8 squared equals 15 squared, and I'm going to do this out super fast. So 8.8 squared is the 77.44. 15 squared is going to be 225. Okay, so now I'm going to subtract the 77.44 and then take the square root. So I'm going to do this minus 77.44. All right, and I get y squared equals 147.56. All right, guys, drum roll for me. And I'm going to do the square root of my answer. And let's see. Whoa, 12.1. Okay, so you can get it multiple ways. And that's saying there are two ways that I could have done this with the 36-degree angle first. Actually, there's four, because you could have done the sine and then Pythagorean theorem. You could have done cosine and then Pythagorean theorem. And that's assuming you did 36 degrees as your reference angle. You really could have done this entire problem using the 54 degrees as your reference angle and had four different ways to do these. So guess what, folks? There are a lot of good ways to do these problems, and I know you can do it. All right, I would like you now to go on and let's look at 15 because I'm making a super long video here. All right, so for 15, this one's a little bit different because you're going to be looking for your hypotenuse. So here you have a 56-degree angle. I do want to find the other angle, so I'm going to do 90 minus 56, and I get 34 degrees. Okay, but I'm going to use this as my reference angle. So I'm going to highlight my hypotenuse. This is H, and I am missing something in this problem. You wouldn't be able to do this problem unless you were given the 16, so you need to have the 16. And then relative to this 56-degree angle, this side is opposite the O, and this side is adjacent. Okay, so we're going to go ahead and write out SOHCAHTOA. Okay, and the side that I know is the adjacent side. So I'm going to do a check, check. So that means for this problem, I'm going to be doing cosine and I'm going to be doing tangent. So, and it doesn't matter the order that you do. So I'm going to say the cosine of the 56-degree angle is the ratio of the adjacent side to the hypotenuse. So I have 16 over x. And this is where I really, really like that switcheroo, that special case, however you want to call it, but that case 2 where the variable's in the denominator, because now I'm going to switch my means, and I'm going to get x equals 16 divided by the cosine of 56. So that will look like 16 divided by the cosine of 56. And I can do that nice and easy on this particular graphing calculator. I get 28.6. Let me show you how you would do that on a phone if you need to. All right, so I'm in degrees. If you're in degrees, then the radian button is there because that would be the conversion button. All right, and I'm doing 16 divided by the cosine of 56. So I have to do 56 cosine and then hit enter, and I get the 28.6. So you can do it with the graphing calculator too. Okay. All right. So now I got my x value. So that is my hypotenuse. So I'm expecting this to be the largest side. Now I'm going to do the tangent. So I'm going to do the tangent of 56 is the ratio of the opposite side to the adjacent. So that's going to be y over 16. Well, wait a minute. I don't need to do that switcheroo because the variable is in the numerator. So since the variable is in the denominator, since the variable is in the numerator, try to speak, you just cross multiply. You're going to get 16 times the tangent of 56. And then you can go right ahead and do that. And you get 23.7 as your answer. And then we can always verify, so I'm going to write those in. Okay, so across from the smallest angle is the smallest side, the 16. Across from the medium angle is the medium side. Across from the right angle is the largest side, and you are good to go. I personally prefer to do the trigonometry twice instead of doing the Pythagorean theorem because these are rounded numbers. There are a lot of decimals that I cut off. So when I did this back here and I used the 8.8, it really wasn't 8.8. This was a different number, and I truncated it. I cut it off. It's a rounded number. So these are a little bit more precise. So if we had gone out more decimals, that can change the values. And then if you use those numbers in a different calculation, it's just rounded numbers. All right, you guys are awesome. Thanks for hanging in there, and I will see you in class.